Okay, so we are recording. Good morning. The chapter 8 slides and the theory in chapter 8 covers a topic that is very uh, commonly used in C sharp. And that topic is this concept of a collection, more specifically a list. And there are other collections besides these things called lists, but lists, in my experience, are the most common collection. So, what is a collection? What is a list? And how are they used? Well, um, if you if you really just break down an array, and if you just think of it very simply, what is an array? Very simply, an array is a storage unit for data. And an array can store a bunch of data. And so, again, I always try and draw that very simple analogy of an array is just a way of storing a bunch of data. A variable stores a single piece of data. An array stores a bunch of data. Typically, your arrays have a single type, like you have an array of strings or an array of ints or an array of what have you. It's just a single type of data. The thing about arrays is that and we haven't really dealt with this too much, but when you create an array, you have to dimension an array. What does it mean to dimension an array? I know it's 8:15 and we're all waking up, but what did it mean to dimension an array, Scott?
Set the number of spaces in memory that
Yeah, yeah, yeah. And so, yeah, so you basically say, hey, this array is going to store 15 elements, or this array is going to store 100 elements or 1,000 elements. It's basically you're setting up how big of a storage unit that you have, right? Are you going to store one piece of data, 10 pieces of data, 1,000 pieces of data? That is dimensioning an array. And the thing about arrays is that once you dimension them, if you want to make that storage unit bigger, like let's just say, okay, I'm going to create an array and it's 10 elements. And if all of a sudden you have an 11th element, that creates some unique problems because it's not as simple as just making the storage unit bigger. You kind of have to move all of your data out of the old array and put it into a new array, right? Because once you dimension an array, it's kind of that size, and there's really just no making it bigger. Okay, so a problem with arrays out of the box is that you just can't make the storage unit bigger. If instead you have a need to store more things and you have units, you basically have to copy the data out of the old array and put it into a new array that has more storage capacity. Okay, and that's doable and that's fine, and you can basically copy the data out and paste it in. If you view it as a copy and paste. And in like a lot of languages from the past, like copying data out of arrays into new arrays, like is just a thing. Like you'd make a loop, you'd iterate over the old array, and you'd paste the values into the new array. The new array would just be dimensioned bigger, and problem solved. However, it is the case that arrays are not dynamic in size. Okay, thus enter kind of a newer storage unit, right? Storage unit 2.0 are these things called collections. Collections don't have that limitation. The limitation being a static size. Okay, collections are dynamic. And it's like, hey, today you could have storage units for 10 elements. Tomorrow you could just make it grow to 11 or 12 or 15 or whatever you need. Okay, so collections, and we're going to focus on, even though there are many collections and we'll go through the common ones, specifically lists are more dynamic in size. So I think of lists as a new and improved array. Okay, arrays have been around in every programming language that I've ever studied, but lists haven't been, right? Lists are relatively newer, especially compared to arrays. Whoops. Christian?
Would you say lists are better than arrays?
Yeah, I would say they're upgraded, right? Lists are an upgrade to arrays. And so then you might say, well, I'm just always going to use a list. And in most cases, that's a good thing. In most cases, I'd say, yeah, just use a list to store your data instead of using an array because they just have some benefits over arrays. Now, when I was talking about arrays initially, I said, look, however, arrays are inevitable. You can't get rid of arrays. If you think you're going to kill off the array and I'm just going to use lists, I'm not going to worry about learning arrays. No. Arrays are inevitable. You will encounter arrays. Other coders will use arrays. They will be a part of your coding journey. So you can't avoid arrays and just focus on lists. Yeah, you might be able to try. That's all right, but they're still there. So lists are kind of arrays 2.0. They're kind of an upgrade. Yep.
Odd question, but can you use them both? Or
Yeah, you can use them both. Absolutely.
I'm
You will
saying
use
in
them
one,
both.
I'm saying in one document, in one project.
Yeah. You can have one programming project that has both arrays and lists. Yeah, Christian.
Is C# the only language that's really done lists?
No. In fact, like Java. I mean, even some of the languages that are older, like a Java, still have lists. Yeah.
So, behind the scenes, are lists just arrays with those does the automatically does those looping iteration and create
If you look at, yes is the answer to your question. If you look at a list in C#, a list is a class, and if you look at that class, if you go to the code behind the list, you will see that a list is really just an array behind the scenes. So it's just a list is doing a lot of operations for you, like copying out of the old array and pasting it into the new. So literally behind the scenes of a list is an array.
So, are there really any downsides to using a list then?
Not. I mean, they're very common. What are the downsides? I don't know of any. I mean, yeah, I don't know of any downsides. And so, one more reason why lists are so common is because in the real world, we store our data in databases. And in the real world, when you have a database, databases have tables full of data. And when you tell your software hey, give me all of your customers, I want a list. I want to retrieve all of the customers, or I want to retrieve all of this customer's orders, right? So I'm thinking of your Amazon account, and you log into your Amazon account, and you click on my orders, and you're looking at a bunch of orders from your past, right? We've all done that. We've all looked at your Amazon account. You're looking at a list of orders. So when data comes out of a database, in many, many cases, when you pull that data out, when you query that data, as they say, that data is coming out of a database in a list format, in a C# list. Okay? And I pulled up a little chunk of code right here. You're not really... The point of this is not to confuse you as much as it is to say, if I'm looking at line 15, look at, this is exactly this little piece right here, context, technicians, where, order by, to list. This is a query against a database. Right? This little bit of code right here is a query against a database. And you can kind of see I'm getting a list of technicians where the technician ID is greater than -1, and we're doing a sort. We're ordering it by that technician's name, and then we're putting it in a list. Line 15 is what I want to highlight. I'm hitting a database here. That database is returning a list of things. That thing is technicians, right? Let me hop on over to my list of products. I'll hop over to my list of products, and I would type list of product. If I could type product, okay? And this is, again, just a similar query where I'm hitting my database. I'm sorting my products by their release date, and I'm putting it into a list. Okay, so I'm hitting my database and I'm getting a list of technicians, or I'm getting a list of products, or I'm getting a list of incidents, right? Here's my list of incidents, or I'm getting a list of customers. Okay, so this is one application that if I just boot this up, by the way, this is something that you guys will all do in later semesters. If I boot this up, here's a website. And if I hit my products page, here's my list of products. So that list of products out of the database is being displayed in this web page, and it's using this C# list in between the web page and the database. And if I go to my customers, here's my list of customers. And if I go to my list of incidents, here's my list of incidents. Technicians, here's my list of technicians. Okay? For those of you in the HTML class, you're going to go, that looks like Bootstrap. And I would say you're right. Right? So we're tying all these things together, right? We're tying in. Here we've got a Bootstrap nav bar. Right? So if I expand that down, looks really familiar, right? Right? We got Bootstrap buttons, primary buttons, right? We got Bootstrap tables, so all of this is responsive as I kind of shrink down. Actually, I would kind of expect that to behave a little better, but that's kind of where it is. Okay? So again, I just want to highlight the importance of a list because it's very real world. When you're pulling data out of a database, it's very common that you store that data out of a database in a list for then use in a website. Again, Mr. Gegelman here, we were just kind of chatting before, and I said, hey, I'm going to talk about C# lists. I said, what was your experience with them in the real world? And, I don't know if you want to chime in or...
We used them for everything. Department of Defense, it was a giant form on the page. So you either input data or pulled it back, but everything got stored in a list, and they pulled all the values out of a list and populated the screen or sent it back to the database out of the list.
So affirmation, so good. I'm glad we're on the same page. He agrees. Lists are important.
Yes. Yep.
And so, again, not to focus on that project. It's really not about that project. So let's let's work with lists. And I will start by just making a Windows Form app. And this particular time, I'm just throwing it in this random repo. This happens to be Hussein's, and I'll just call this chapter 01 and list demo. But yeah, kind of moving forward as you guys are doing these labs, and if you think you have a bunch of data to store in a storage unit and you want to use a list, by all means, feel free to use a list. So I just want to kind of start with a simple, like maybe click a button, put data into the list, and then pull data out of the list. Like that's kind of where I want to start. Put data in, pull data out. And so in this button, I'll go to properties and I'll say view list data. And we'll call this btn submit. And I'll double click. And as of right now, remember there's kind of two places to create variables. You can create class scope variables, and the place to do that is underneath the curly brace where it says public class. And so I'm going to create my class. I'm going to create my list here. It's done with the keyword list. Now the syntax for this is a little bit different. You see these angle brackets, or what these are called. These kind of look like HTML brackets, right? Angle brackets. They're the same characters, right? So in HTML you have paragraph tags, so on and so forth. It's the same characters. In C#, this is something called a generic. And right now what that means is that for us, how this applies is you can put any of your data types in here. Okay, so we know data types: int, floats, doubles, chars, strings. You can put, and as you saw, I had a list of customers. So it's very flexible with the type of data. Okay, so a generic is generic. It kind of can accept any type. Okay, so you can make your own custom generics, but for right now, we're not doing any of that right now. Let's just have an int, a list of integers. And I'll just call it my ints equals new list of integer. Now, so this is the syntax for creating a list. Now, we haven't talked about a lot of how to put data into an array. We saw the shorthand syntax, and that does in fact exist with lists as well. So if you know the values going into your list, there is this nice shorthand syntax, and that gets the data going into our list. So this is a preferable format for me. I like the shorthand syntax. There's a lot going on here. We've got these angle brackets on both sides. We've got this keyword new, which means object. If you guys are listening right now, put this in the back of your memory because this will be important. Anytime you see this keyword new, just realize that is creating an object. Okay, and I realize that might not mean a whole lot to you right now, but there's something going on here with this classes and objects. And remember, we talked about these programming terms in chapter 2, and I said we're going to dive deeper in this class, right? Which we are. We're going to dive deeper into classes and objects and this new keyword. But we are in fact creating an object here. Its data type is a list of integers. It's worth noting here that anytime you see this color here, this light blue, I can actually hold down Control, and do you see how my cursor changes to a clicker? My cursor changes to a hand, I should say. If you click on that, you can actually inspect the C# code for a list. And I mentioned briefly that behind the scenes that a list is an array of items, and that is demonstrated right here. Here, what do these brackets represent? These brackets represent an array. Okay, now we're not going to understand all the code that's written here. I just want to show you that by holding down Control, if you ever want to go behind the scenes and see kind of what is happening under the hood, as they say, which is always a good idea, you can hold down Control, click on one of these classes, and kind of inspect. Okay. I said I want to put data in and I want to pull data out. Well, I've put data in. Now let's just try, out of the sake of demonstration, of course, it's a list of integers. If I try and put a floating point number with a decimal, that's not going to work. Of course, if I try and put a string like my name in there, that's not going to work. it is pretty strict. Okay? There are structures actually that exist where you don't have to have a strict type on your list. Okay, and the book kind of talks about like this array list. An array list, not recommended. Okay, an array list is this structure, is this collection where it's like, hey, I can store ints and I can store doubles and I can store floats and I can store strings, kind of like in JavaScript where you can just kind of store whatever you want. But it's not typically recommended to do that, especially for beginners, because C# is a strictly typed language. You want to keep everything strict. Okay, this is a strictly typed list. It is a list of integers. It only works with ints. Very similar to arrays, I'm going to use a for loop, and I'm going to iterate over my list. Now, when I was looping over strings, I would use the length property. When I was looping over arrays, I would use the length property, right? So we've kind of looped over two things in this class so far. We've looped over arrays and we've looped over strings. You know, looping over a string is an array of chars. Looping over an array just kind of goes through the array one element at a time. For whatever reason, when you have my ints, which is a list of ints, there is no length property. So you might guess my length, or my ints, dot, and if I type in length, you're going to see there is no length property, which is a little unfortunate because that's what you guys have looped over so far. You've always used this length property to help control your loops. However, and I hit dot, there's a suggestion here that you can see, which is count. And if you read the IntelliSense or the tooltip there, if you read the tooltip, the count gets the number of elements contained in the list. Well, that's nice. That's nice. So let's loop over the count. Instead of the length, we're looping over the count. Obviously, you can count 1, 2, 3. Certainly, you can count that there's 3 elements. So point is, it's not. Now, you might have noticed there's a different property here. Capacity. Capacity is the number of units of storage. So the capacity can be different than the count. The capacity can say, well, I can store 10 things, but I only have the count of 3, right? Count is to say how many things are in there. Capacity is how much storage do I have. Okay, and I'll demonstrate how there can be a difference here. I'm going to make a little label here and demonstrate the capacity. Well, before I do that, I'm just going to loop over my ints.count, and I'm just going to put a result label. So I'll go into my toolbox, I'll drag and drop a label, and I'm going to delete the text. I'm going to call this label result. Okay. Let me bring this back, and I'm going to loop over label result dot text equals my ints sub I to string. Now, instead of just putting the piece of data, I'll say this. I'll put a little string interpolation here, and I'll say the data stored in the list is, and I'll say my ints sub I. Okay, and so the idea here, and then I'll put a line break with a new line character. Okay, so put data in, pull data out. That's all I've done so far. And I've taken way too much time talking. Okay. Any idea why it's doing that? Every time through the loop, I'm reassigning the text property. And so it's not showing me 1, 2, 3. It's only showing me the last one, which is 3. So if I just reassign the text every time through the loop, it's just overriding that text property every time. Maybe instead what I want to do is append every time. And there we go. The data stored in the list is a 1, a 2, and a 3. So it is pretty nice that we get to, this is a syntax, again, because this is an array behind the scenes, to pull the data out of the list. It's the same syntax of pulling data out of an array. And putting data in is pretty similar. Now, I've never talked about this little method right here. You guys, has everyone, I mean, look at this, everyone's seen this, and maybe you just kind of like, I don't know what that is, I don't want to touch it, don't touch it, right? And that's the safe thing to do at this point. Okay, I don't know what that is, don't touch it, okay, cool. Next chapter, we're going to talk about methods, and this is a special method called the constructor. And like later on, we're going to learn in detail about this method. Right now, we haven't learned about this method, but a method, basically, this is a method that runs when your form is booting up. And so, like, obviously, I hit Control F5, I'm running the form. When this form is constructed, aka it's being built in memory kind of thing, this method runs. And so if I need to put an executable line, if I need to put an executable statement, like I want to add something to my ints, okay, one place that you can put that is inside of a constructor. So, you know, what I wanted to demonstrate here is I can put data in when the list is created using this shorthand syntax. But then after the fact, let's just say you want to ask the user for some input and then add that to your list. They make it nice and easy. They make this method called add. And this method called add is going to put a number, and I'll just say 40, right? It's going to add this number to the end of my list. And that might, in fact, change its capacity. Now, the list has a default capacity. I need to talk about like what are its defaults and how it grows and shrinks. But the add method will kind of just handle the capacity. If it needs to grow the capacity or if it needs to redimension the list, it'll just redimension the list. It'll handle it for you. You don't have to redimension the array or the list. It will redimension it for you. All right, now notice I add 3 numbers kind of here, but then later on, when this form is constructed, I add the next one here. And now if I boot this up, of course, I should get that new value, right? So the add method is used to add a value to a list after it's constructed. You would say it's constructed right here when you see this new keyword. Now, pretty simple. We've done a few things. We've put data in. We've pulled data out. This is a good time to show you guys another loop. If you understand a for loop, there's another loop that's very commonly used with both arrays and lists, right? So if you were disappointed because you said, oh man, there's only do, while loops, and for loops, there is a shorthand syntax for this for loop. And it's called for each. Again, when we're talking about very common control structures, a for each loop is very common. Now I'm going to use a code snippet. I'm going to hit tab, for each tab. And it fills this in. First off, this keyword var is an interesting keyword. If you've taken the JavaScript class, you've seen the keyword var. We kind of learned to avoid it in JavaScript, right? Because there's var in JavaScript has been upgraded to let and const. So var is kind of the old way of variables in JavaScript. C# vars still exist. In fact, if you were paying close attention to my earlier example, you might have seen me using var. But I'm not going to use var here because I haven't explained it, and I want to explain it later. I want to say for my data type here on my for each loop is a list of integers. Actually, I think I just need to say a single integer item in. Now notice it says collection. My code snippet says collection. Well, what's the identifier of my collection? My identifier is my ints. So I want to say my ints. Okay. This is a shorthand loop. Okay. How many people right now are beginners and don't, be honest here. How many people are beginners and like you're learning loops for the first time and it's challenging and frustrating and you're like, I don't quite have it down yet. I need to continue to learn, right? I need to continue to learn. Okay, a good handful of people. Okay, this for each loop is a simplified for loop. So if you don't like the for loop, it is important to understand, but it's also worth saying that this for each, which one looks more complex? Line 20 or line 25? Line 20 is more complex. This is to say I'm going to loop over all of the elements inside of my ints, and then on each iteration of the loop, the items are just going to be called, the elements are just going to be called item. The identifier will be item. So check this out. I'm just going to take this piece right here, put it inside of my for each loop, and then here I just say item. So now it says for each item in my ints. Okay, so that same question to those of you who are learning for loops for the first time, would you all agree, at least on the surface, right, that line 25 looks a little bit easier than line 20? A couple people are awake and shaking their head yes. That's a good thing. All right, I would hope that for those who are struggling, you would actually take a look at this line of code and go, okay, maybe I can get into that. Maybe I can get into that one. You're going to notice that this shorthand for each loop does the same exact thing. I have an array of ints, so we say for each integer item in my ints, print out that item. So the way this works, and Ryan, go ahead and ask your question.
I guess my question is, what's the difference between the, so instead of teaching us for,
why not just do for each?
Yeah.
Great question. Ryan's question is, hey, instead of teaching for, why not just teach us for each? A couple of reasons. The primary reason is this. For each is known as a read-only loop. And what I mean by read-only is all I can do is read data out of an array. But remember how when we were using, or a list, remember how we were using arrays in the beginning? We were doing two operations. We were putting data in and we were pulling data out using loops. And so the answer to your question is that this for each loop can only be used in one of those two operations. For each loop is only used to pull data out. So you have to, if you're going to use a loop to put a bunch of data into like a list or an array, you have to use the traditional for loop. Okay. It's also the case that this for each loop, again, we kind of talk about like the older ways of coding and the newer ways of coding. For loops have been around a lot longer than for eaches. And so, again, kind of like arrays, for loops are kind of inevitable. Like, it's the older way of coding, but you're not going to get around it. Like, you're going to have to know both. Does that make sense?
Yeah.
Good answer. So but the biggest thing here is that basically for loops are used with collections and arrays to do two operations, but this for each loop really just does one of the two operations. But yeah, I like for each, and there you have it. I want to introduce this concept of capacity versus count. Remember, capacity versus count. Capacity is the size of the storage container. Count is the number of elements in the container. So I just want to kind of take a look, and right here, I'm going to take this line out. I've got 3 elements, so my count is 3, but I'm kind of curious about the capacity, right? I believe, I remember in Java there was a default capacity of 8, so I think that's the case in C#. Again, C# and Java are like basically the same. C# you could think of as a newer Java. But I just want to demonstrate. So if I do label result.text, and when this form loads, I'm going to say this. I'm going to say the capacity of my list is, and I'll say my ints.capacity. Okay, okay, it's 4. I was wrong. It's actually smaller. So notice the count is 3 because there's 3 elements. If I change that, check this out. I'll say, and then I'll say plus equals the count of my list is my ints.count. Okay, so I just want to, the capacity is 4, the count is 3. If I put a new line in here, just make that a little bit cleaner. Everyone can see the capacity is 4, the count is 3. So as a demonstration of how lists just kind of redimension the capacity automatically, watch what happens when I add a 4th element. Okay, the count now is, the capacity is full. Okay, any guesses what happens when I add the next element? Any guesses what happens to the capacity? Obviously it's going to go bigger. Any guesses? By 1, by 10, what do you think? By 4? We have guesses? Good guess. It was by 4. The capacity doubles. What happens when I fill it up with 8? 6, 7, 8. Obviously we are now at capacity. What happens when I add the 9th? Does it go by 4 again? Turns out it just keeps doubling, right? So the capacity goes to 16. You put in the 17th element, it'll go to 32. You put in the 33rd, it'll go to 64. It just doubles. The capacity doubles. It starts with 4, and then it just grows by doubling if you fill it up. So that's cool. Yeah.
So is it just reserving another bit?
It's just reserving more space. Yep. It's just reserving more space. Now, you might agree that in this case, I've got 9 things and I've got 16 storage units. Might seem like a waste of space. And in 2023, it's okay to waste a little bit of space. You really don't have to be that efficient. But they do make a method, my ints dot, I believe trim excess is actually going to, no, that's not going to work. again, you don't have to do this.
Or wouldn't you have to put it before where you say capacity?
Oh, you're right. I did. Good eye. Good. Sets the capacity to the actual numbers of elements. So if you look at the tooltip right there, it does do. I put my order of operations wrong, which was a good eye to find that. So if I trim the excess, now I can actually say, okay, the capacity is 9, the count is 9. Okay, that kind of gets rid of the wasted space. Not super important to do. Again, you're probably not trying to balance it that much. Point is, big takeaway here is just to realize it kind of grows automatically for you, which is nicer than arrays. Arrays do not redimension as they grow. That's another reason, that's the main reason why lists are considered better than arrays. So here, I've got 9 elements in there. If I want to add a 10th, let me just add a 10th. I'm going to put this back in here. I'll just add in a 10th element. And again, you're going to see the capacity is still 16, the count is 10. So if you're manually looping over it, you want to loop over the count. You don't want to loop over the capacity, right? You want to loop over the count because that's how many numbers are actually stored in there. Well, let's just, since we're doing this, since we're adding new elements, let's just my ints dot. Well, again, the tooltip pretty much spoils the question. The question is, well, what do you think the clear message does? Well, if you think of what, it's pretty obvious. Fortunately, they try to make this intuitive, right? So they have a method called clear, and clear would remove all of my elements. So even though I put them in, then I take them right back out.
So it keeps the capacity.
Keeps the capacity. Yeah, because once it grew, it doesn't then grow back down. Yeah. Yep.
Can you manually resize the capacity? Like increase to like a set number?
Yeah. And so if I want to increase it to a set number like 100, yeah, that should do the trick. The capacity is 100. Yep. So if you know that you got 100 customers and you just want to say, hey, do that, there you go. Yep. Good question. All right. Let me boot that down. And let's see what else is in there. If you want to remove, removes the first occurrence of an object from the list. So I'm going to call remove, and I'm going to remove the number 5. The first occurrence of the number 5. If I had multiple number 5s, it doesn't remove the second or third or fourth occurrence. Okay, now if I view the list data, yeah. The data stored in the list is 1, 2, 3, 4. Obviously, it's missing the 5. I've removed the 5. So, useful methods that we've covered. We've talked about add. We've talked about a trim. I think it was trim to, what was it? Trim to something? Trim excess. Thank you. And remove. These are useful list methods. As far as the properties, we've talked about the count and we've talked about the capacity. So these are the basics of a list. There are more basics, but I tell you what, we're going to send you on a break and we'll cover some more basics when you get back. All right, so I'll pause the recording. All right, folks, we're going to resume and kind of finish up our discussion around a list. When you even start down the book, you know, there are other what are called collections. A list is not the only collection. There are, and the book will even expose you to like 6 or 7 collections. I want to start with lists and kind of master the list a little bit before you expand on into trying to understand other collections. I think by understanding one well, it will be your foundation for understanding others. Okay, and so I'm not going to spend a lot of time in this class on hash tables and on queues and on stacks and these other array lists, on these other collections that exist, when in my experience the list is the most commonly used, and therefore I just kind of want to focus on that versus kind of learning a bunch of them not very well. I just want to focus on learning one well. And so I think I'm trying to offer a more practical approach into learning these. What I've demonstrated so far are these properties called count and capacity, as well as adding a new element to a list, which, keeping in mind, adding it kind of adds it just to the end of the list. So it puts the number at the end. And removing, we'll just remove the first, for example, if you remove a 5, it'll remove the first 5 in the list. Okay, but what if you don't want to remove the first 5 in the list? There's also a way. And so I want to talk about a few more methods. Be it contains, insert, remove at, binary search, and a sort, and what the heck, we'll even throw in a find. Okay, and find is a little bit different. And so let's just kind of get rid of my add and my remove and bring this back. And I'll just kind of get rid of my loops or my notes here. And even I'll get rid of my for each loop and just kind of bring this back. And I'll just bring back a default list with no set capacity, and I've got 9 numbers 1 through 9. And here we have contains, and so contains is the next method that you can do something like if my ints dot contains a number, like does my list contain a 3? So you can use the contains method to return true or false, and because it returns true or false, you can use it in an if statement and do something like, yes, the value of 3 is in the list, or just the value is in the list, else label result.text not found in the list. Okay, so contains returns Boolean, true or false. I've hard coded the value of 3. If I click the button, it says yes, the value is in the list. If I put 30 in here, that should return false and say not found in the list. And so contains, again, the naming is intuitive. Is this value contained in the list? Yes or no? True or false? So that's the contains method. Insert. Well, insert might sound a lot like add, and it is. The difference is add automatically puts it at the end. Insert gives you flexibility, and you could say, I want it here. Insert it into this position. So notice these are 9 elements of which they have subscripts 0 through 8. And so maybe I want to insert the value 10 somewhere in the middle. Okay, so let me do that. So when this is loading, I have a list of ints called myints. Myints.insert. And notice, again, these tooltips, kind of hard to read on the big screen, but if you're looking at my screen share, it says insert an element into the list at an index. Okay, and notice if you pay close attention to those parentheses, it says integer index, comma, int item. So inside the parentheses, the first number that you pass it is the index that you're going to put it into, and the second value is the value that you're inserting. So I'm going to insert, I don't know, into the third index. So 0, 1, 2, 3. It'll be the fourth item. So I'm going to make the fourth item the number 40. So it should go 1, 2, 3, 44, right? And I'm going to for each over my loop. For each integer called I in my ints, let's label result.text plus equals I and append 0, 1, 2, 3, 40, 4, 5, 6, 7, 8, 9. It worked. I can make it prettier by doing some sort of like line break here. I might make it a little prettier. It's not the point. But now 1, 2, 3, 40, 4, 5, 6, 7. We have now inserted into a specific position. You have control, right? You don't have to just add to the end of a list. If you want to put something in the middle for whatever reason, you can do that. You might guess what the sort will do for us. Right now, these numbers are not sorted. They're close to sorted, but 40 is obviously greater than 9, right? So if you have an array, there are methods that we didn't examine inside of arrays, but in some languages you don't have the ability to sort. There's no built-in feature to sort. And in an array list, we do have that feature. So if I go into here and say my ints dot sort, this is alphanumeric. In other words, it can sort alphanumerically, so alphabet letters as well. Yep.
Is sorting exclusive, or rather like on lists on C#, or can you do it like on others? Like
you can do it in some languages, not all. Yeah. And so if I kind of go into here, now I spit this out. Now 40's at the end because we're going in ascending order. So again, we've talked about contains, Boolean, true or false. We insert at a certain position. We've sorted. We'll talk about a search. And there's actually two searches that I've got here. One's called find and one's called binary search. Find's actually really useful in many cases. If insert allows you to put something in at a position, well, remove at will be different. So let me get rid of my insert. So my data is this: 1, 2, 3, 4, 5. And let's just say I've got another 5 at the end of the list. Remember that a remove removes the first 5. Well, if I want to remove the last 5, well, that is at a position of 9. There's 10 elements. Index is 0 through 9. So you'd have to remove the index of 9. Right? That should remove the 5th element here. So let me remove my sort. And let me do my ints dot remove at. Again, the tooltip is your best friend here. I don't have this stuff memorized, but I can use a tooltip to remind me how to work with this stuff. This says removes the element at an index. So what index did I say? Well, I said the 9th. Let me double check my work. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 elements. Indexes are 0 through 9. So let me just go ahead and add another one at the end here. So let me just remove that 5 that would be at the 9th element, and then I'll loop through. So that second 5 should not be there, and in fact it's not, right? So we removed the second occurrence of a 5 that was at the 9th element. Yes, sir.
So what would be the point of, like, with having removed there, why don't you just not put it in the code?
That's a good question, right? So why not just delete it right here? Is the question, right? A lot of times these lists are not statically configured like this. Like what we have here is we have a statically configured like data set. A lot of times though, we're not getting our data set from just hard coded like this. Again, we might be hitting a database and your database might have a list of products and you're trying to remove one of your products from the database, right? You're a company, you got 10 products and you're just trying to delete a product, right? So you take it out of the database and remove it, kind of thing. And so the question is, and it's a good question, it's like, hey, why put it in and then just pull it out is basically what the question is. And the answer is, well, what is in is not really always up to our control. Like what the data is in our control. We're just responsible for making it able to take something out. And that's really what that does, right? So that's a good question. These two methods I think I've talked about all of these. All that we have left is find and binary search. Binary search is exactly what it sounds like. It is going to search for an element and return if it's found or not. Very similar to contains. But contains returns true or false. Like, yes, this list does contain the name Bob, right? Binary search does the same thing, but instead of returning true or false, binary search just returns an index. And so let me show you a binary search. I'll say int position equals my ints dot binary search. Again, tooltips. If I hover over binary search, this one's a little bit more complex as far as the tooltip is concerned. If I look inside here, I see 1, 2, 3, maybe 4 items to pass, but it's not required to pass all 4. Some of those are optional. So I'm going to say binary search for the value of 3. And, well, 3, what index is 3 at? It's at index 2, right? So position should hold the index of 2. And if I update my label result.text equals the position of the value 3 is, and like Lexa said, it should say the position of value 3 is the second position, or position 2. And then I'll put in a little line break, and that's all happening on plus equals. I forgot to do plus equals. So that just gives you the position. Of course, you could use the position as the subscript to spit the value back out. I could say something like this, the value is, and I could say my ints subposition, and again, this position is position 2, my ints, it's basically going to spit out the 3. The value is 3. Now let's see what binary search returns if I feed it a value like 11. There is no 11. There is no 11 inside of my list. And so that would actually break my program. And if I go to run this, it's not working because position is a -1. When it doesn't find the value it's looking for, like let me just print out the position. The position is position and not use it as a subscript. Because 11 doesn't exist. Oh, actually it does say -1. Where's that 2 coming from? Pretty sure binary search returns -1 if it's not found. I'm
You know, the count is 11. Does it like do the opposite?
Yeah, it is a negative value. Thought it was -1. It's giving me -12. Not so important. Point is, it returns a negative value because if it's found, it'll be 0, 1, 2. It'll be the position. If it's not found, a binary search is pretty useful, but I also like a find. And so the last method I'm going to talk about here is find. This syntax is different than all the rest. The find syntax is very useful though. And so let me just kind of start by typing my ints.find. And you can see it kind of takes in what's called a predicate. And ultimately what I'm looking for is a value that you define as x, where x is equal to 10. And so this syntax on the find is a little bit different. We will explore the syntax a little bit more in detail, but there is the value of 10. And this, the difference between int find results equals, and let's put find results here. Okay? So find is very useful because binary search just gives you back the index. But check out what find gives you. Find gives you the value back. So you can do something like find x where x is, greater than 8. And it's going to give you the first value that's greater than 8. This is the last thing I'm going to say before I'm done lecturing on lists, okay? Find is a great tool to search through the data in your arrays because it allows you to not just get back an index or a position in your list, it allows you to get data back. We can write queries using find like, hey, I'm going to find anything greater than 8. Find if I have a value greater than 8. And the first value greater than 8 is 9, and so the find results, when you do a search in that manner, it's going to give you the value back. So that's different than like a binary search, because binary search just gives you a position back. It's not giving you data back, it's just giving you a position. Okay? So covered in details a lot to deal with lists. My recommendation for you guys is start working with lists moving forward. If something could be an array, consider getting it into a list instead. And
With binary search, can you do like the x greater than 8?
binary search does not allow you to do that. No. This is called a lambda expression, or actually they called it a predicate. But yeah, you can write this kind of lambda expression where you're searching for values like that. Yep. Yep. Just current to where it is right now. I'm done with this page, yes. And so I can take this snippet and put it in Discord, yes. Yeah, of course. But obviously there's a lot that I deleted along the way, but if this would help, then absolutely. All right, I'm going to stop the lecture there.